Okay, so as a reminder, okay, I like to put parentheses around that instead of that dot. Okay, so problem number one from Exponential Functions Day 1. What I'd really like to point out today is how I can get answers from just the function. All the answers I can get from just the function. That is really a lot of information, okay? But let me go ahead and put our table of values here. I should have used -2, -1, 0, 1, and 2. You are going to need at least 2 decimal points, okay? At least 2 decimal points in your table of values so you can get a good idea of where that curve is, okay? Now, you should have gotten -1.25, -1.5, -5, -10, and -20, okay? So that should be the table that you got, okay? So now, let's look and see what information I can gather just from the function and this table. First of all, I know that A is -5. I know that B is 2 because with exponential functions, our equation is y equals A times B raised to the x power. So A is what's on the outside of the parentheses, B is on the inside. So I've got those two. And because it's exponential, I know that the x-intercept is none. Okay. Also, I'm kind of hoping you might have picked up as you work these, picked up on the pattern of the y-intercept. For the y-intercept, the x has to be 0. What is the y value? Anybody pick up on that pattern? -5. Because the y value in the y-intercept is the a value. The a value is the y value in the y-intercept. Awesome. Good deal, Dennis. Now, the ending behavior I'm going to need to see. Okay, but the domain I know is all real numbers. It's exponential. It has arrows on both ends. Because it's exponential, I know that that's going to be my domain. I also know that my range is going to be compared to 0. Because exponential functions always go right up against that x-axis without ever touching it. Okay, so I know it's going to be, my range is compared to 0. Now, I can go ahead and get my inequality from that because if my a value is negative, then that tells me that 0 is my highest number, highest y value. So if it's negative, all my answers are going down. So y values are less than 0. So if my a is negative, y is less than 0. All of the y values to my function are going to be less than 0. So let's check that out. When I graph my points, -2, now my x and my y axes are both counting my ones. Okay, so that's good. We like that. -2, -1 and a quarter, -1, -1 and a half, 0, -5, 1, -10, 2, -20. So when I graph that, I'm going to turn it sideways so I can get really close to that x-axis. Just don't touch it. Okay. And then I start coming. I'm going to bring that point down just a little bit. Just so. Okay. So here's my curve. Okay. Here we go. Oh, make sure you put an arrow on that end. And here's my curve. As it comes up, it's a pretty sharp curve. Okay. And so it should look something like that. So your curve should look something like that. And hopefully it looks a little smoother than that. Mine looks a little jagged like a dog's hind leg. But it's okay. It's going in the right direction. So we're going to be happy about that. Questions about any of that so far? Okay. Yes. Okay, thank you. Now, my ending behavior. As x approaches negative infinity, okay? Here's x approaching negative infinity because it's going to the left, okay? My y values, remember this is this axis. As my x's go to the left, my y values are kind of going up, but then they curve on around. So this is where y is approaching 0. Okay? Now, when x is approaching positive infinity, y is approaching, so now I'm looking at as x approaches positive infinity, so I'm going to the right. Here's my y. What are my y values doing? Approaching negative infinity because it's going down. Okay? Okay? So, questions about number 1 on your homework.
When we make the table for the x and the y,
Mm-hmm.
instead of stopping at +2, I stopped at +3. Is that okay?
Okay, well, here's my question, Devish. Is that going to fit on your coordinate plane?
No, it's not, but I saw you do it on the practice problem. That's all.
Okay, yes, you did. Okay, and no, it's not wrong, Devish. It's not wrong. But what I'm telling you is you can stop. The reason I do the extra one is so that you can see why, like why 3 wouldn't work. So you don't have, because you don't need to show me why 3 doesn't work. Does that make sense? But
thank you.
But if you do, it's fine. That's not wrong. Okay?
Oh.
Thank you, Devish. Okay. Now, any other questions about exponential functions day 1? Okay. If there are no questions, we're going to put that to the side or put that away. And now we're going to talk about day 2. Here we go. Now, the process is the exact same. There's nothing different here. Nothing different. And we're not going to do example 1 because I just did an example of what we've been doing. Because what we're doing today that is different is we're using a fraction in the b position, okay, instead of a whole number. All right, so we're going to see what that does. So that is the main focus today is what does a fraction, how does a fraction change what my graph looks like? Okay? Nothing else different here. So here we go. As we look at the first one, and if you have a graphing calculator, as I've said, just use it. Okay? Just use it, get your table of values. You don't have to sub in, but if you need to sub in, then you need to do that. Okay? So I'm going to go ahead and give you the table of values, okay? And I need y'all to keep in mind that I can't see your writing. So you're going to have to let me know if I'm moving too fast. You're going to have to ask me to slow down or chat and ask me to slow down, okay? If you need a chance to get things written down, because I can't see you, okay? Now, here we go. Our table of values, we're going to start with -3. And as a reminder, if you are doing this by substituting in for your homework, 3 is a good place to start. Start at -3 or +3, depending on which way you're going. And that'll give you your place. If it's too large or too small for the y, don't use it. But that's your good kind of guide there. Okay? So for -3, when x is -3, y is 16. If x is -2, y is 8. If x is -1, y is 4. If x is 0, y is 2. If x is 1, y is 1. If x is 2, y is 1/2. So that's not enough, because remember, I need at least 2 decimals or fractions, depending on how you look at it. I got to go one more, and if x is 3, y is 1/4. Now, I do want you to know that this table of values is all about you. If you need to change these to decimals so that you know where you are, you can do that. I don't need to see it. Okay? You just do it. This is about you. Table values is all about you and what you need to do to get ordered pairs plotted in the right place. Okay? Okay. So that being said, now let's talk about our characteristics that I can gather just from looking at my function here. Because I can get most of them just by gathering information from my function. The value of A is 2. The value of B is 1/2. The x-intercept is none. The y-intercept, starting with 0, right? Because 0 has to be the x value. And looking at this, my A is my y value. Okay? But also, you can look at it here in the table of values. I'd expect you to be able to find that in the table of values, because where x is 0, we have a y-intercept. End behavior we're going to look at in a moment, but I know that the domain is all real numbers, and I know that the range is compared to 0. And I have to have an inequality symbol there because there's an arrow on the end, so it has more than one answer. So if A is positive, that means that I'm going to be up against the x-axis and then I'm going up. So all of my answers are going to be greater than 0. Okay? And this is a good check also. If you do it this way, then when you graph it, you can double check and make sure that you have your function going the right way. Okay? So let's plot these ordered pairs and see if we've got that correct. So, -3, +16. So I'm on the x-axis down here. I'm going to go to -3. Both of my axes are counting by 1. Yay, we prefer that. So 16, -3. Nope, say backwards. -3, 16. Now, -2 on the x, +8 for the y, -1, 4, 0, 2, 2, and half, 3, 1/4. So that gives us a good idea of where our curve is. Now, look at what a fraction does. A fraction in the B position just turns, make sure you got an arrow on there, Now, as a reminder, I did not plot 4, so as I come up, right, my function should still be between 3 and 4 here. Okay, then we're going all willy-nilly over here. I didn't plot 4, so we're still between 3 and 4, so that'll help guide that top part. Okay, so this is what happens when you put a fraction in the b position. Now my function is whooshing the other way, right? My L is in the opposite direction. So let's see what that does when we talk about ending behavior. So as x approaches negative infinity, right, y is approaching, so let's look at that. So x is left when it's negative, so I'm approaching negative infinity to the left here with my x's. Where are my y values approaching? Well, they keep going up. My arrow says I'm going up. So now y is approaching that positive infinity. When x approaches positive infinity, so let's talk about the other side of that. Y is approaching, so now I'm looking where x is approaching that positive infinity. Well, as my x's are increasing, heading towards positive, where is my y approaching? Well, it's approaching that 0 it's never going to get to, right? Because remember, this is never going to intersect, never going to cross it. So now y is approaching the 0. Questions? Okay. No questions, we're ready to move. Okay, so let's look at one more example. And what I want to look at this time is example 5 here. Okay, I want to look at example number 5. So I'm looking at this one right here. And I'm going to gather the characteristics that I can just from the function. So let's do that. So my a value always in front, negative 3. My b value is 1/2. The x-intercept is none. Why? It's an exponential function. Has arrows on both ends. So every point on that exponential function has an x value. Okay? Now, my y-intercept, I now can do just from my function. 0, comma, a. Okay? Ending behavior, we're going to leave that till we graph it. Okay? My domain, all real numbers. My range is compared to 0. Now, my a is negative, therefore, what? Okay, I'm ready. Thank you, Mr. Arnell. Okay, so my y is going to be compared to 0. Because my a is negative, that means I'm going to be coming up against this x-axis, but whichever way it comes, it's coming down. So 0 right here, there's my 0. All of my y values are going to be less than that. Negative, less than 0. So that goes hand in hand. Okay? Questions? Are we good? All right, let's try our end behavior. Let's see what we got here. As x approaches negative infinity, y approaches, do you know? Nope, that's why you have to have your table of values. So let's do that now. Okay, this is what you've got to, you need to graph it so you can see it. Now, if you have a graphing calculator, you can just push graph, right, and look at the picture and know. All right, but I still have to have that table of values. You still have to graph it, so you can use your table on your calculator if you've got it. We're going to start with negative 2. So when x is negative 2, y is negative 12. When x is negative 1, y is negative 6. Okay. When x is 0, y is negative 3. When x is 1, y is negative 3 halves. When x is 2, y is negative 3 fourths. Okay? So we've got our ordered pairs. Okay? And we're going to plot those. So negative 2, negative 12. Here we go. Negative 1, negative 6. 0, negative 3. And then here are my two decimals or fractions. If you don't know, negative 3 halves is actually negative 1 and a half. So that's going to be about right there, negative 1, negative 1 and a half. And then 2, positive 2, negative 3 fourths. About there, not quite 1. Okay, so we see where our curve is happening. Okay, so we're going to come right up against the x-axis, and we're going to start to curve to connect our point. Make sure you've got an arrow on that end. Okay, and then we're going to come on up. Now, as a reminder, I did not graph 3, so as I come up, this has to stay between 2 and 3. Come on that, and there that is. Questions? Okay. Alrighty. So, as x approaches negative infinity, here we go. Going to the left for my x values, and this is on the left side, so that's negative infinity. Where is the y heading toward? Well, it's heading down, so the y is approaching negative infinity. Okay? Now, as x approaches positive infinity, y is now approaching, oh, here we go. My x values are going to the right, so that's my positive infinity. Now the y values are approaching that 0 it's never going to get to. Okay? It's approaching it, just not going to get there. Any questions? Okay.